While the vastness of space sparks our curiosity, the most extraordinary celestial body might very well be our own planet, Earth. With its expansive oceans, breathable atmosphere, and protective magnetic field, Earth is a remarkable place that stands out in the universe. It is not only unique in that it hosts life, but it also serves as our home. Despite our long history of exploration and study, there remain countless mysteries about our planet. What exactly makes Earth so special in the cosmos? What have we uncovered about its diverse systems and rich history? I'm Alex McColgan, and you're watching Astrum. Together, we will embark on a journey to explore the wonders of Earth. Context. Let's start by providing some context about our planet. You may have heard it described as pear-shaped or egg-shaped. While it is true that Earth isn't a perfect sphere, these comparisons can be misleading. The planet has a slight bulge at the equator, resulting from its rotation, creating a difference of about 45 kilometers between its equatorial and polar diameters. This means that the furthest point from Earth's center isn't Mount Everest, but rather Chimborazo volcano in Ecuador, due to its position near the equator. On average, Earth measures about 12,742 kilometers in diameter. Historically, Earth has fascinated scholars, philosophers, and scientists who sought to understand our place in the cosmos. Age-old questions, such as whether the universe revolves around us or if we orbit the Sun, have led to significant debates. The idea of a spherical Earth dates back to ancient Greek thinkers in the 6th century BC, but it was the mathematician Eratosthenes around 240 BC who first estimated the planet's circumference. He noted that during the summer solstice, the Sun was directly overhead in Syene, now Aswan, Egypt, while it cast shadows in Alexandria. By measuring the angles of these shadows, he accurately calculated Earth's circumference. The 16th century heralded a dramatic shift in our understanding of the solar system with the advent of the heliocentric model. Pioneers like Nicolaus Copernicus proposed that the Sun, rather than Earth, is the center of our solar system. This revolutionary concept was further validated by the mathematical theories of Johannes Kepler and the observational insights of Galileo Galilei. Today, we recognize that Earth is the third planet from the Sun, part of a group of 4 terrestrial planets characterized by rocky surfaces. Time. Earth orbits the Sun at an average distance of approximately 150 million kilometers, varying between 147 million kilometers at its closest approach, perihelion, and 152 million kilometers at its farthest, aphelion. This journey takes about 1 year, which aligns with our calendar system. However, the way we keep track of time is more complex than it appears. In fact, Earth requires about 365.25 days to complete one orbit around the Sun, which is why we add an extra day to our calendars every 4 years in a leap year. The concept of a month is historically linked to the Moon's orbit around Earth, with the terms month and moon deriving from the same root. The Moon takes roughly 27.3 days to complete its orbit, creating a mismatch with our calendar months, which complicates the synchronization of lunar and solar timekeeping. Moreover, our days aren't precisely 24 hours long. A sidereal day, the time it takes for Earth to rotate 360 degrees relative to distant stars, is approximately 23 hours and 56 minutes. The reason we use solar days, based on the position of the Sun in the sky, stems from Earth's orbital motion. Each day, as Earth orbits, it must rotate slightly more than 360 degrees for the Sun to appear at the same position in the sky, accounting for the additional 4 minutes. These variations extend further due to Earth's elliptical orbit and axial tilt. The length of a true solar day can fluctuate by as much as 30 seconds throughout the year. To address these fluctuations, we utilize mean solar days, which average the variations over the year. Interestingly, tidal forces from the Moon gradually slow Earth's rotation, lengthening our days by approximately 2 milliseconds per century. While this may seem insignificant, it has profound implications for Earth's geological timeline. Models suggest that 500 million years ago, days were shorter than 22 hours, resulting in roughly 400 days in a year. Rotation. The rotation of Earth can be beautifully captured in time-lapse photography, where stars appear to traverse the sky, highlighting the planet's rotation. The interplay between Earth's axial tilt and its orbit around the Sun causes the Sun's position to change throughout the year. This phenomenon is visually represented in an analemma, a figure 8 shape created by capturing the Sun's position at the same time each day over a year. Each planet would produce a distinct analemma based on its own rotational characteristics, orbital parameters, and axial tilt. Earth's axial tilt of about 23.5 degrees is critical for producing seasonal changes. Interestingly, the temperature variations between seasons are primarily influenced by the angle and intensity of sunlight, rather than the distance from the Sun. During the summer months, regions receive more direct sunlight, resulting in warmer temperatures, whereas in winter, sunlight spreads over a larger area, leading to cooler conditions. Even though Earth's closest approach to the Sun occurs in January, this proximity does not significantly affect seasonal temperatures due to the vast distance of 150 million kilometers, which dampens its impact. Atmosphere. As sunlight reaches the Earth's surface, it warms the land and oceans, releasing heat back into the atmosphere. Our atmosphere is relatively dense compared to other celestial bodies, but it has a low overall mass. It consists primarily of approximately 78% nitrogen, 21% oxygen, and 1% argon, along with trace amounts of other gases, including carbon dioxide. Water vapor also plays a significant role, varying between 0.01% and 4%, depending on local conditions. This variable water vapor content is crucial for cloud formation and precipitation. Earth's atmosphere is essential for sustaining life, providing the necessary gases for respiration and shielding the planet from harmful solar radiation. The greenhouse effect, caused by gases like carbon dioxide and methane, helps to maintain a stable temperature on Earth by trapping heat. However, human activities are altering the composition of the atmosphere, leading to climate change and other environmental challenges. Conclusion. In conclusion, Earth is a remarkable planet with a complex system that supports life in myriad forms. From its unique shape and rotational dynamics to its atmosphere and the passage of time, there's much more to discover about our home. As we continue to explore